The National Electrical Code, or NEC, mandates the segregation of neutral, or white wires, and common, or bare copper wires to individual bus bars within electrical panels. This requirement is detailed across several articles within the NEC. Firstly, Article 250.24 specifies that neutral conductors shall not be used for equipment grounding. This means the neutral wire's primary function is to carry the return current from the electrical load back to the source, and it should not be used as a path for grounding electrical equipment. Secondly, Article 250.146 states that the grounding electrode conductor, the grounding electrode system, and all other grounding conductors shall be connected to the grounding bus within the panel board. This grounding bus serves as the central point for connecting all grounding conductors, ensuring a low impedance path to ground for fault currents. Thirdly, Article 310.15 (2) addresses the identification of neutral conductors in lighting and appliance branch circuits, stipulating that they shall be identified by white or grey insulation. This clear identification helps electricians easily distinguish neutral conductors from other types of wires, reducing the risk of wiring errors. Fourthly, Article 310.15 (3) specifies that equipment grounding conductors shall be identified by green with yellow stripe, or bare copper insulation. Like the white or grey insulation for neutral wires, this distinct coloration allows for quick identification of grounding conductors, promoting safety and accuracy in electrical installations. The segregation of neutral and common wires is crucial for several reasons, with safety being paramount. Separating these wires prevents accidental cross-connection, which could lead to electrical shocks or equipment damage. If a neutral wire is inadvertently connected to a grounding conductor, it can create a path for stray currents to flow through unintended routes, potentially energizing metal parts of equipment and posing a shock hazard. Adhering to the NEC guidelines is essential for code compliance. Electrical codes are put in place to ensure the safety and reliability of electrical systems. Segregating neutral and ground wires as required by the NEC. Electrical installations meet the standards necessary to prevent electrical hazards and maintain compliance with local and national regulations. Isolation is another key benefit of keeping neutral and common wires separate. This separation ensures that the neutral and grounding systems remain isolated from each other, which can prevent interference or other electrical problems. Grounding systems are designed to provide a low impedance path for fault currents, while neutral systems carry the normal return current. Mixing these systems can lead to ground loops, noise, and other undesirable effects. In most modern 200 amp breaker boxes, a typical configuration involves two grounding bus bars, one designated for neutral connections and the other for grounding connections. The neutral bus bar, typically identified by a white marking, is dedicated to connecting all neutral conductors. This ensures that all neutral wires have a common point of connection, simplifying wiring and reducing the chance of errors. The grounding bus bar, often marked in green, is used to connect the grounding electrode conductor equipment, grounding conductors, and any other grounding conductors. This bus bar serves as the central point for the grounding system, providing a secure and reliable connection to ground. Several important notes should be kept in mind when working with electrical panels. The grounding electrode conductor must be connected to the grounding bus bar first. This connection is critical for establishing a solid reference to ground, ensuring that the grounding system can effectively dissipate fault currents. All other grounding conductors, including equipment grounding conductors, must also be connected to the grounding bus bar. These conductors provide a path to ground for metal parts of equipment, protecting against electrical shock in the event of a fault. Neutral conductors should be connected to the neutral bus bar after all other grounding conductors have been connected. This sequence ensures that the grounding system is properly established before the neutral connections are made, minimizing the risk of accidental cross-connections. In summary, segregating neutral and ground wires in electrical panels is not only a requirement of the National Electrical Code, but also a fundamental practice for ensuring electrical safety and reliability. By understanding the NEC requirements, the reasons behind them, and the typical panel configurations, electricians and homeowners can maintain safe and compliant electrical systems. Ignoring these guidelines can lead to dangerous situations and potential code violations, underscoring the importance of proper wiring techniques. It is imperative to consult the latest edition of the National Electrical Code and local regulations for the most up-to-date information and requirements related to electrical installations. Proper training and certification are also essential for anyone working with electrical systems, ensuring they have the knowledge and skills necessary to perform their work safely and effectively. The NEC guidelines are comprehensive and address various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment specifications. Familiarizing oneself with these guidelines is crucial for anyone involved in electrical work, whether they are professional electricians or homeowners undertaking DIY projects. Electrical safety is not just about following code requirements, it's about understanding the principles behind those requirements and applying them in a practical and responsible manner. Electrical systems can be dangerous if not handled properly, and even seemingly minor mistakes can have serious consequences. Taking the time to learn and understand electrical safety practices can significantly reduce the risk of accidents and injuries. Moreover, technological advancements in electrical systems and equipment continue to evolve, necessitating ongoing education and training to stay abreast of the latest developments. New materials, wiring methods, and safety devices are constantly being introduced, and it's important to understand how these innovations impact electrical installations. In addition to the NEC, other standards and regulations may apply to electrical work, depending on the specific location and type of installation. Local building codes, utility company requirements, and industry best practices can all play a role in ensuring the safety and reliability of electrical systems. It's important to be aware of all applicable regulations and to comply with them accordingly. Furthermore, regular inspections and maintenance of electrical systems are essential for identifying and addressing potential problems before they become hazards. Over time, wiring and equipment can deteriorate due to wear and tear, environmental factors, or improper installation. Regular inspections can help detect these issues early on, allowing for timely repairs and preventing more serious problems from developing. When performing electrical work, it's always advisable to de-energize the circuit or equipment before starting any work. This can be accomplished by turning off the appropriate circuit breaker or disconnecting the power supply. Always verify that the power is off before touching any wires or components. Additionally, using appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses, can provide an added layer of protection against electrical shock and other hazards. It's also important to use the right tools for the job. Using the wrong tool can not only damage the equipment, but also increase the risk of injury. Invest in quality electrical tools that are properly insulated and designed for the specific tasks you'll be performing. When working with electrical panels, it's important to keep the work area clean and organized. Clutter can create tripping hazards and make it difficult to work safely. Keep tools and materials neatly organized and clean up any debris or spills immediately. Moreover, avoid working in damp or wet conditions, as water can significantly increase the risk of electrical shock. If it's necessary to work in a damp environment, take extra precautions to protect yourself from moisture. It's also important to be aware of the potential for arc flash, which is a sudden release of electrical energy that can cause serious burns and other injuries. Arc flash can occur when there is a short circuit or other fault in an electrical system. Wearing appropriate arc flash PPE, such as a face shield, gloves, and flame-resistant clothing, can significantly reduce the risk of injury in the event of an arc flash. In conclusion, electrical safety is a critical aspect of any electrical installation, and adhering to the National Electrical Code guidelines for segregating neutral and ground wires is a fundamental step in ensuring a safe and reliable electrical system. By understanding the reasons behind these requirements, following proper wiring techniques, and taking appropriate safety precautions, electricians and homeowners can minimize the risk of electrical hazards and protect themselves and others from potential harm.